Okay, we're going to go over problem 35 from the 2015 June Geometry Common Core exam. This is the first of the 6-point problems on the exam. There are 2 of them, so I'm going to be going over both of those in this video. All right, so let's read the question here. It says the water tower in the picture below is modeled by a 2-dimensional figure beside it. The water tower is composed of a hemisphere, so we have a hemisphere here, a cylinder, and a cone. Let C be the center of the hemisphere, and let D be the center of the base of the cone. All right, so let's go down to the actual, let's go down and see the rest of it here. It says if AC is equal to 8.5 feet, which they label here, and BF is equal to 25, which they also label here. Sometimes they don't label for you, and this they did on this problem. And then it says an angle EFD, the measure of angle EFD is 47 degrees, which is right here. They labeled it all. So they want to determine and state to the nearest cubic foot the volume of the water tower. All right, so we know we have to do that. There's another part to this actually at the bottom, but let's focus on the volume. So, all right, actually, I'm looking at your test now. This is actually over the course of two pages here. All right, but so let's find the volume. So we have a hemisphere, a cylinder, and a cone. All right, so the first thing, we have to find the volume of 3 different figures, or 3 different shapes. So we need the volume of the hemisphere. So we have a hemisphere. And that is going to be down here. Remember, hemisphere is half of a sphere. And we need to know the volume for that. That is on your no, matter of fact, I take that back. It's not on your reference sheet. Let's go to the reference sheet here. Now, you have the volume of a sphere, but you need to know that the hemisphere is half. So, we've been talking about this in the class. The volume of a hemisphere is 2/3, so V is equal to 2/3 pi r to the third. So 2/3 pi r to the third. So you have to know that a hemisphere is half of a sphere. If you don't know that, you're not going to be able to do this. All right? Okay, so we have that. Now, do we have everything that we need? Well, we know that if we have a sphere, or half of a sphere, this length here that I'm about to outline is 8.5. We need to have the radius. Matter of fact, the only variable in this equation, well, no matter of fact, there are 2 of them, volume and radius. But if we have the radius, we can find the volume. So if this is 8.5, then that means that this is also 8.5, this side, which represents the radius. So the volume of our hemisphere is going to be, volume is equal to 2/3 times pi times 8.5 to the 3rd power. And once you do that, that is equal to, get out my calculator here, that is equal to, let's see, I'm going to do this on the calculator here just so we see what value we get. We can see it together. All right, so I'm plugging in now. I'm going to use the alpha y equals to get my fractions. I'm going to do 2/3. And that's going to be pi per second. My pi, I'm going to use parentheses here, 8.5 to the third. Enter. And now I would definitely use all of these numbers. Do not round until the very end. Do not round to the very end. So let's use all of these numbers. So let's write, so it's 1286.2204. Well, matter of fact, if you use 4 numbers, you'll probably be safe. If you want to use all the numbers, go ahead. But 4 numbers, you'll probably be safe. You know, since I already said I'll write all the numbers, I'm just going to write them all this time. We'll write them all. All right? Can't go wrong with writing them all down. So 220392. 220392. And remember, volume is cubic, and this is cubic feet. So we have cubic feet. All right, that is the volume of the hemisphere. So we have that. All right, we also need the volume of the cylinder. The cylinder is in between here. So it's actually this part right here. Right? If you look here, it's going to be right here. All right, remember, the cylinder is volume equal to pi r squared times h. The only difference from that and the area of a circle is that you add in the height being multiplied. So the volume of a cylinder is equal to pi r squared h. Now, again, we need the r, we need the h. Well, the h is represented by this, 25 feet, and the radius is the same as the radius of our hemisphere, right, 8.5. So we end up with V is equal to pi times 8.5 times 25. All right, so if I put that in the calculator, I'm going to end up getting, I'm going to do this actually by hand here, so you won't see it up there. Hopefully you have a calculator. So I'm going to go second pi 8.5 squared times 25. And you get 5694, so our volume is equal to 5,694. And then I'm going to do to 4 decimal places this time. All right, so we have that. So that's our volume of our cylinder. Now we need the volume of the cone. So what is the volume of a cone? So let's do the cone here. So the cone, the volume is equal to 1/3. And the reason why it's 1/3, the only difference between the cone and the cylinder is the 1/3. For those of you who watched the video I showed, or I showed a video in class, to where there's a demonstration of a cone and a cylinder of the same height, and they had the same radius, and it took 3 cones filled with water to fill up the cylinder. So that would mean that the cone can hold 1/3 as much as the cylinder, which is why you have the 1/3 here. All right, so that's our formula, and we're going to plug in now. Now, for this formula, we need the height and the radius. So let's go to our cone, which I'm outlining here. Now, we have the radius, because that's going to be the same thing here, so it's 8.5. So we have the radius, but we do not have the height. The height is represented by what I'm pointing to right here. So what you have is, I'm going to get a different color here. All right, what you have here is actually a right triangle. So I'm going to draw it down here, where you know the degree. Over here, you know an acute angle. You know it's a right triangle. You're looking for x, and you know this side is 8.5. Right? At this point, when you see an angle and you're looking for a side, you should start thinking about using trig, using your SOHCAHTOA, sine, cosine, or tangent. All right, so, because we need that height. We need the height. We don't have the height of that cone. And in order to find the volume, we need to have the height. So, looking at this triangle, we need x, which I've labeled as x. So our reference angle or our acute angle, based on that angle, the x is the opposite side. So we are going to be using the opposite side, and we have the adjacent side. So the hypotenuse is not involved because we're not looking for it and we don't have it as a piece of information. So if you look over here, the only one that uses the opposite and the adjacent side is the tangent. It's tangent. So we're going to use tangent, and we are going to do the tangent of the angle. So tangent of 47 is equal to the opposite, which is x, divided by or over the adjacent, which we know to be 8.5. Okay, so we can cross multiply at this point, so I can just have that as, so what I'm going to have here is 8.5 tangent 47, and make sure your calculator is in degrees. When you take this test, there is no reason for you to be in radians. And when you get your calculator, it'll probably be in radians. So you should switch it to degrees quickly. All right, so now that's our height. Now, if you want to be exact, you could just keep this as your height. If you want to get a decimal, just make sure around to like 4 places. But if you want to be exact, just use what I just circled as your height. 8.5 tangent of 47. So, all right, now we're going to have, now we can plug our height into our formula. Oh, by the way, if you do a decimal, let me tell you what it will be. 8.5 tangent 47. And again, I was in radian mode. I could tell by my answer, so I need to switch 2 degrees. And hit enter. And so I'm going to do 8.5 tangent of 47. You know what? I'm going to show you this in the calculator because you need to see this. All right. Now, what I'm talking about is the mode. Now, I'm already in degree. But if you were in radian mode and you did this, 8.5 tangent of 47, you get this value. That's not right. So you need to be in degree mode when you're dealing in degrees. So we're going to do 8.5 tangent 47, and enter, and you get 9.11. If you want to be sure, you can either write down all those numbers or at least go to 4 decimal places. So that's going to be 9.1151. Matter of fact, I'll just use that value, 9.1151. All right, so our volume now. Our volume is equal to 1/3 times pi. Now our radius is 8.5, and our height 9.1151 is what I put. So times 9.1151. And once you do all that, you get a volume of 689.6487. All right, so we have our 3 volumes. Now we're going to go ahead and add them up. Go ahead and add them up, and you end up getting, let me get a calculator and add up these 3. So what are we adding up? We're adding up, what I'm about to highlight here, we're adding up this. We're adding up this. and we're adding up this. And these are all in cubic feet. All in cubic feet. All right, so we're going to do 1286 point. So I'm going to do some calculating and I'll be right back. All right, when I went back, I saw a little mistake that was made in calculating. This actually here should have been a 7, and I actually forgot to put the square here. So it's actually 5674. And so I'm going to add up all of these values. And you end up getting, once you do all that, 7,650, and it's actually 0.37. But if you go back up to the question, it says to the nearest cubic foot. So if you round that to the nearest cubic foot, it's going to be 7,650 cubic feet. All right, so we just found the volume of this water tower. All right, we'll go and do the next part. All right, there's more to this problem. Let's keep going. It says the water tower was constructed to hold a maximum of 400,000 pounds of water. If water weighs 62.4 pounds per cubic foot, can the water tower be filled to 85% of its volume and not exceed the weight limit? Justify your answer. There's a lot to this problem. We've already been through a lot, and now there's even more. All right, so this water tower was constructed to hold a maximum of 400,000 pounds of water. Okay. So if water weighs 62.4 pounds, what we're going to have to do is think to ourselves, if it were full, how much weight would it be holding? So for each cubic foot, water is going to weigh 62.4 pounds. So if it were full, this is how much weight would be in there. Be the volume times 62.4, which is equal to 477,360 pounds. That is pounds. So if that water tower were full, it would be holding this much weight, which is not possible because it says it was constructed to hold a maximum of this much. So for whatever reason, you're not going to be able to fill up this water tower, because if you fill it up, it's going to exceed the weight limit, which is kind of strange, this problem is kind of strange. But according to this problem, this water tower cannot be filled because if you filled it, it would exceed the weight limit. But what it's asking is, can it be filled to 85% of its volume and not exceed the weight limit? So we have to take this total weight and multiply by 0.85, which is 85%. That gives us 405,756. Again, at 85% of its capacity, it would be holding over 400,000 pounds. Well, that's not going to be, it's not going to be able to hold that. If it can only hold 400,000 pounds, then it's not going to be able to hold 85% the weight that it would be at if it were 85% full. Because this value is greater than 400,000, the answer is no. Because the question is, can the water tower be filled to 85% of its volume and not exceed Exceed means go over and not go over the weight limit. And the answer is no. And here's your justification right here. Right? So there you go. And I think that's gonna be it for this time. I'm gonna go to the next question next week.